definition we hand out. And basically, it's an abstract class that implements a tree traversal. That doesn't do anything. To implement a tree traversal that actually does something, all we have to do is we extend the visitor pattern. That means we inherit all those empty visit routines, and then we re-implement methods that represent the nodes that we want to visit. So if I want to go through and print something out for every method decal, I will re-implement visit method decal in this extended visitor, and that's it. And remember to visit children if needed. I mean, if there's nothing below you in the tree that you need to look at, there's no need to go there, right? Okay, so we had that. Then we had two things. We had all the names that could be referenced without the definition being defined. So the names that can be forward referenced. And also, what was special about some of these, or all of these names that I'm going to show you, or write down here now, was that the scope of them was always the same. We know that the scope of a class is the entire program. We know that the scope of a method is inside the class and its subclasses, unless we put private on it, so on. So names that can be forward referenced with predetermined scopes. Those are names of classes, methods, fields, inits, well, constructors they're called, right? And static inits. So a total of 5. So in the class and member finder, we have to implement visits to those 5 things. And let's just quickly recap again what to do when we hit them. Now, what should I do when I get to a class? Well, put it into the global class table. So this needs to be inserted into the global class table. What about methods? So methods, static initializers, and constructors are inserted into, I call it the current class, but really it is the enclosing class, so the class in which they appear. So they just go into the current class's method table, and fields is inserted into the current classes field table. Okay. Different color here. The method table, sorry, the global class table looks like this. I don't know, A. There's a class decal. And a class decal has field table and the method table. Name value, field table, little a, points to a field decal. And over here, I don't know, foo, points to another table where we have the signature here. And then that points to a method decal. Okay, so I have to implement these 5. I have visit class decal, visit method decal, visit field decal, visit constructor decal, and this is static int. When I go into, or when I enter the visit class decal method, I'm holding on to the class decal. I can insert it into the global class table. That one can be seen anywhere, so any class can be used anywhere if we can find it in that table. And of course, what we're going to do is we're going to hook onto that table, onto this class decal, so that when I go and visit the children, then I know which classes, field and method table, I should insert things into. Then I go and visit the children. At some point, I might hit a method, a field, a constructor, or a static initializer. And since I hold on to this class decal, I'm actually passing that as a second parameter. Remember that visit method had 2 parameters. It had the type of whatever it was you were visiting, and then it had something of type, what was it, object, and we'll just pass the current class there. So that second parameter can always be cast to a class decal if we remember to pass it. And in that class decal we have a field table and a method table. We actually have 2 methods. We have add field and add method. We'll look at those in a second. And I did mean to write those for you. It seems, apparently.
That's very nice.
Yeah, but it's in phase 4. Oh no, wait a minute. It's in the second part of this. This is the class and member finder. There's a name checker, so you have to write find method and find field, I believe. I guess I figured if it weren't inserted properly, then there's no need to go look for it, right? Okay, so when we get to these methods, fields, constructors, static initializers, we make sure they get inserted into the right places. Remember, these guys go in with the name CL init or class init, and these go in with the name init. Funny init. That was British humor. So let's see. So what do we have left to do? Well, we still have names whose scope depend on the location of the declaration. And, well, whatever we have left now would be parameters and locals. Okay. I think we did last time write down what the scope of these were, but let's just do it again so that we agree. What's the scope of a parameter?
Open bracket and closure. Well, depends. Was it clear? Yeah.
So,
Can we
After
reference
the,
the
Method is called
method?
the method that's
the
in
column, right?
no,
After
it's,
the column where
how about we just say the body?
body.
Let's not make it too complicated, right?
technical term.
That was easy, because it's the entire body, right? No matter where you are in the body, you always have access to your parameters. What about locals?
At their semicolon, but before the end of the block here.
Yes. So, from the end of its declaration to the end of the closest enclosing block. Now, if the scope of a parameter, well, the parameters are really not that bad because they are pretty fixed. It's the entire body. And if the scope of a local happened to be the entire body as well, then all we really had to do was create a table associated with a method. So let's just try here. So if I say void foo int x int y int z dot 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 if something int w something else int u dot dot, then what's the scope of x and y? Well, that would be all of this, right? So that's x and y. What's the scope of z?
X and Y. I mean the whole thing.
After the
No, it's not the whole
Well,
thing.
from declaration to the
Well, it's
closing.
important that it's from declaration to, because if I were to say, if you say it's the whole thing, then I'm actually allowed to use z in the initialization of itself, and you can't do that. You can't say int z equals z plus 1, right? So we have to have encountered that semicolon. So it's really from here, right? And then all the way down. So that's z. What's the scope of w then?
From its declaration to its enclosing bracket.
Right. So there you go. What about you? Which unfortunately we're out of colors now. That sucks. Blue light here. The purple is here. So what do we say?
after you, down to the end of the block.
After me?
After you.
After you.
No, I want you to do it.
I got it.
So something like that. Okay, so now we have to find out a way of creating an algorithm that determines if, well, let me put some uses of some variables in there as well. So basically this entire exercise is only for one thing, and that is to determine if I have the use of names that are not declared. Oh, I was smelling the wrong color. The orange. So really, what we want to do in the end is just to find out if we have a reference to an illegal name. So are those name references okay? So U, W, X, Y, and U again. And how do we determine that?
Upper one,
You-
involving U,
It's been declared.
hasn't been declared yet. It's not within the block that we described for use, so
Okay.
that one's easy.
One below should.
You got the value in the second one, but that's not.
Well, that's the last lecture. We'll deal with that of the year. So how? Let's say that I'm sort of coming along here that I have on this U here. How do we determine if that U is declared?
Check our hash table.
Yeah, just do.
What hash table?
Hash table we should get for this guy.
Oh, okay, so we should have some hash tables, i.e. some symbol tables like these guys. And where should I glue some of those onto?
You mean onto this picture specifically?
No, now we're over on that picture because they're not gonna fit in with these because that's it for those. These are now set up. Now I can use these to look things up. I mean, if I have, let me make a little bit more. Well, I can fit something in here. I'll make that curly bracket smaller. And then if I say foo of little a comma x, then I know if I have, oh, by the way, what parse tree node would that create?
Method.
This.
Oh, the node?
What parse tree node? You spend the whole week doing parse tree nodes.
Our brains got mush-ified.
Cloud. Oh, invocation, yeah.
I'm going to go find all your phone numbers and start calling you in the middle of the night and harass you on this. I'll set up a robocall thing. Hi, are you aware? If you think it's invocation, please press 1. What names appear in an invocation, for sure? Oh, the name of the method that I'm invoking, right?
Mm-hmm. And parameters, price, in this case a sequence.
It's a sequence of expressions. Yeah. So not quite mush. Yet.
Yeah.
So if I have to look at this and say I want to determine if the use of all these names is legal. Let's start with the use of the name food. How do I find out if I can legally use food? Not considering private, public, and all the modifiers, but simply, is there a method declared called food?
Go to
Methods
flow.
table.
Plus table.
There. Is there a foo in there? Yes.
Sorry.
Wonderful. We can call it. That's a valid reference of the name foo as an invocation of a method. What about little a?
Little a hasn't been declared yet that I can see, so oh, it's a field table. We'll check that out.
You forgot that, right? So, what about x?
X is valid.
X is
Or
valid.
hash table.
So, how did you determine x was valid?
It was
In the parameter table.
Hmm?
Well, you go to field table again.
No, that's not a field.
Well, oh yeah, no, it's a parameter.
That's a parameter.
So you have to go inside the enclosings method and then go and see the parameters of that method. And
Yeah, unfortunately, that's just what? Okay, so what parse tree node is that? Type. We agree with the sequence of expressions. That was a sequence of expressions, right?
Mm-hmm.
So that makes that something that inherits from expression.
A bar? Well, no.
No, that doesn't inherit from expression.
Sorry. No.
What expression consists of just a name?
I don't
Oh,
know.
that must
Name
be a
expression.
name expression.
That was a hard one. Okay, so just looking at something, well, the A is also a name expression, right? Just looking at it, I can't tell whether it's a parameter, or whether it's local, or whether it's a field without a target. That could be a local field, right? So, what are the rules? Should I look at parameters and locals before I look at fields, or should I look at fields before I look at parameters and locals?
Each one, like local, I think takes priority over parameters, and I think parameters takes priority over fields.
If they're named the same.
If they're named the same in this case.
Right. So the idea is if I want to resolve a name that could be a local, so this could basically be a local, a parameter, or a field without a target. The target is that thing that happens before the dot, right? So basically what I'm trying to do is I'm trying to look further up in the code to see if I can find a local or parameter declared with that name. And then I can say if I get to the top and I've looked in the parameters and I didn't find it, then go look in the field table and see if you can find something there. So we have to have some way of exploring, because I mean, what happens if I put a W here instead? A W is declared above, but it's still not valid, right?
So then just go with this.
Because it's not in the scope. So maybe we could do something like this.
But it's not going to, yeah, it won't be on the tree, on the branch of the tree that you're supposed to look at anyway, right? Is that what we're getting to?
Well, so you're saying by looking back up in the parse tree?
Right, it will be in a different branch, or it should be, shouldn't it?
Yeah, it would be.
Right?
You want to shoot that one down?
No.
Unfortunately, one of the problems is that you don't have a parse tree in which you can get the parent. Have you noticed that? You can get your children, but you have no idea where your parents are. That's why when I implement these 5 methods over here, I have to pass the current class as a parameter because I can't figure out who my parent is. So there's really no easy way of doing it. But I mean, we could do the following. Once I get to a method decal, I open a new scope in the form of a table, and then put in there x and y. And of course, they point to param decals. And then I have a pointer, or we can't call it a reference, called current scope, and I make that one point here. Then I get to the body. A body is really a block, right? You see the curly brackets. And blocks can have things declared in them. And in particular, I could redeclare x and y, which means that if I wanted to, I could put int x here. And if I did that and I wanted to try to put x into this table, we would get a problem because we'd have 2 x's and we wouldn't know which one was the right one. So associated with this block, let's make another table. And then if I ever have to go look something up, if I can't find it here, then go and look in the one that represents the closest enclosing scope around this table, which is the previous one. Okay, now we can then say the current scope is no longer that, but it is this. All right, then I'm going to start the body now. I'm going to work my way down. Oops, I get to a declaration. All right, so insert that here. We have a local decal. So basically, these tables can hold any kind of decals, right? All right, we move down. We get to an if. Let me put something in here real quick. Let's say if x is less than z plus a. So all of a sudden I have the use of something. I have the use of x, z, and a. how do I find out if those have been declared? Well, easy enough. I go to my current scope and I look here. Is X here? No. Look at the previous one. Is X here? Yes. Okay, fine.
So you are linking those blocks?
The tables?
Yeah.
Yes, I am. I have to, right?
Yeah,
Because
I was wondering.
no, you have to, because if you didn't link these two, then by looking things up here, you get to the end of it and you wouldn't be able to see your parameters, right? So what I'm really doing here is I'm making a chain of current enclosing scopes.
So at the end you can't look at your parent. Well,
No, you can't look at your parent in the
actual
punch tree.
class,
You
yeah,
can
but-
look at the parent scope.
Yeah.
Sure.
Okay, yeah.
Okay, we get to Z. Look it up in the current scope. Oh, there it is. Good job. So, there we go. And A, is there an A here? No. Is there an A here? No. So I could actually make a field table, the parent table of the one holding the parameters. Or if the lookup failed, then go and look in the field table of the current class. Either way is fine. Whichever one you choose to do works equally well. Okay. So onwards and upwards. Here's a block again. So that requires the opening of a new scope. And into that we get W, which points to a local vector. And we're in here now. U, is there a U here? No. 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 U is not defined. So that doesn't work. You see how this works really easily? Now X, is there an X? No. Is there an X? No. Is there an X? Yes. So X was good. W, is there W? Yes, there is. That was a local to this scope, so we're good to go. Now what happens when I get to this curly bracket here?
Pass out the current.
We have to throw this scope away because no longer can we see W. Oh, I forgot to update that. Because when I opened that scope, this thing of course pointed there. And now you said throw away the scope. So that means since I'm no longer inside this block, I close down this scope and I reset my current scope to point to the previous one. Okay. So onwards and upwards through, we've dealt with A. Is there an A? No. Is there an A? No. Is there an A over there? Yes, so that's good. Is there an X here? No. Is there an X there? Yes. Oops, now we hit the declaration of int U. What should I do to U?
Pass it on the method table.
No, that's not a method table, it's a symbol table.
There you go.
So there's U.
Doesn't this have a problem when it's back at U because it wasn't,
No.
didn't find it? Okay.
Why?
Because U wasn't declared.
Yeah, we also produced an error.
Oh, you did produce the error, I'm
See,
sorry.
look,
Yeah.
that's a negative sign.
Gotcha.
Or, yeah, you blow up and say, screw you, this didn't work. Or continue and catch more of them, whichever you want. So now I declare U, and it gets put in the same table as Z, right? So when we drew this, red and green and purple, it looked like U and Z were in different scopes, but they're really not. But U doesn't appear in here until I get down to here. Of course, I can't just go through the entire scope and say, let me get all the declaration and throw them in and now go do the resolution. I have to put those in as I go along. And that's what I meant when I say that the scope, the names whose scope depend on the location of the declaration. So I put U in, and now I can go down and look at Y. No Y, there's a Y. U, there's a U. W, oops, no W. So that one is illegal as well, right? Now I get to the end of the curly brackets representing the body. So I will get rid of that. Update current scope to here. And now I'm done with that. And I get rid of that table altogether. So what we need is well, we already have the symbol table. And remember I said last time, oh, there's some stuff at the bottom for opening and closing scope.